problem number 7. We're being asked to multiply here. Part A looks like a FOIL problem. 2 sine x times sine x would be 2 sine squared x. The outer term is minus 6 sine x. The inner one is plus 5 sine x. And the last looks like minus 15. I have a couple of like terms in the middle, so minus 6 and plus 5 makes minus sine x. And that's it. There's no other like terms, so I'm finished. Part B, I can't distribute exponents when I have a plus like that, so I'll have to write this out as a FOIL problem. It's 2 cosecant x plus 1 times another copy of itself. And then I can start my foiling. I've got 4 cosecant squared x. Looks like the inner and the outer are going to be the same thing. I'm going to get a plus 2 cosecant x in each case, so when I add those together, that'll make 4 cosecant x's. And then plus 1 at the end. And again, no like terms, so I'm finished. Part C, that's one of those conjugate situations, so this one's going to be pretty fast. 1 times 1 is 1. The outer and the inner wipe out. It's plus sine squared x and minus sine squared x. The last would be minus, and then sine squared times sine squared, that means I'll have 4 in all, so that would be sine to the 4th x. And there's the answer. Part D is kind of like part B. I'll have to write this out the long way. And then I can FOIL. I'm going to have 9 cotangent squared x. The inner and the outer will match. They're both 3 tangent x cotangent x's, so 3 plus 3 is 6 of those in all. And then the back part appears to be tangent squared x. At first glance, it certainly doesn't look like this simplifies, but you always have to look carefully with trig functions. The one that does simplify here is that middle term, because what I can do is reciprocate one of those functions to the bottom. So for example, I have 6 tangent x. If I take cotangent x and reciprocate it to the bottom, it becomes tangent x, and then those tangent x's cancel out. So that middle term is actually just equal to 6. I can't really do anything with the rest of it, but my final answer is going to be 9 cotangent squared x plus 6 plus tangent squared x. Now we'll go backwards in problem number 8. The goal is now to factor, to take these answers to multiplication problems and write down the original problem. The first step always is to look for a GCF. So in part A, I have 2 terms. I have a sine x that's in common to both. So I can pull that out to the front, leaving me with cosine x here and 1 of the sine x's here. There's no way I can continue factoring, and so this is the answer. Letter B, there is no GCF. However, this does fit the difference of squares pattern. Those are both perfect squares, and I see a minus sign in the middle. So it's going to fit that A plus B, A minus B pattern. A would be sine x, and B would be 3. Again, these are very easy to check. If you just multiply that back out, you will get sine squared x minus 9. Letter C, I do have a GCF of 3, leaving me with 1 minus cotangent squared x. Now remember, the goal here is to factor, and so what I see in that parentheses is another difference of squares. This one keeps going. It fits the A plus B, A minus B pattern. A would be 1, and B would be cotangent x. So 1 plus cotangent x and 1 minus cotangent x. And then part D, what do I have in common? A bunch of signs. It looks like there are 4 signs in common to each term there. So I'll pull out all 4 from the first term, leaving me with cosine squared x. And I'll pull out 4 of the ones from the second, leaving me with 2 left, sine squared x. Now that's certainly the answer to the factoring problem. I can't factor any further, but the directions do say if you can simplify the answer at the end, go ahead and do that. And of course I see cosine squared x plus sine squared x is 1, which means this in the end is just equal to sine 4th x.